Okay, I want you to take a look at the screen now because I need you to notice that I've changed one very important thing on you. I've changed your instruction. That instruction for the first three problems was simplify. And now I'm asking you to solve. So I have changed that instruction on you significantly. Solving requires something totally different. So what I'd like you to do then is to jump in and try to solve the two equations that you see on the page. All of question one were expressions. They were never equal to something. They just have a value to them. Well, now we've set our expressions equal. So what allows me to go through and solve is the fact that I have equal signs in each expression. Okay, I want you to give it a shot. So go ahead and solve those two equations on your own, and then we'll come back and we'll check. Okay, pause it now. Okay, we're back. So you take a look at the equation given to you in problem A, and I really think that there was only one really bad mistake, and it's taking a look at the right side of that equal sign. The left side of the equal sign should have been pretty automatic for us. That is, I think a lot of people would have liked to have simplified the left side. The big mistake that can come up on that right side right now would be to say 5 minus 3 is 2, and then expand a 2 into those brackets. I hope that you can see that if you were to work through that, you just broke your number one rule in math. You just broke BEDMAS. That when you take a look up on the right side of the original equation, you have two operations. Those operations are subtract and multiply. We know in BEDMAS we have to go through and deal with multiply first. And so I've got to leave that 5 out in front, and maybe we expand in that 3. Maybe we spend one more line. I don't know if we like to do this. Feel free if you like. I don't think it's necessarily a bad thing to simplify both sides of the equation first. And now we can go through and solve it. I'm going to bet and say we've kind of got one of two paths. That you may be the sort of person who likes to put their variable on the left side. So, to get rid of a plus 6x, you are going to minus 6x. And that's what gives us our negative 8x on the left side. Now, to get rid of your plus 6, we are going to minus 6. And that's what's going to give us our negative 4 on the right side. That maybe you are a left side variable person, and now we could go through and solve that. I would hope that we could skip this line of saying getting rid of times by negative 8 means I divide by negative 8, and we could simply go straight to a negative divided by a negative is a positive, and 4/8 reduces to 1/2. Now, you may also be a positive coefficient person. I would throw myself into that category. That I take a quick peek at my last purple line, and I like to have positive coefficients. So I'm going to think about my variable being on the right side then, because then I will have a positive 8x over there. To get rid of my minus 2x, I need to add 2x. Now that means I need my constants on the left, so to get rid of a positive 2, I need to subtract 2. At the very least, what that does is that allows me to go through and avoid the whole sign issue. Now I can simply jump to get rid of a times by 8, I divide by 8. 4 divided by 8 is the same as 1/2. I would love it if you were the person who wrote this down on your page to work to stop writing this. This always kind of drives me nuts. And the reason it drives me nuts is because I think if we know enough to write the divide by 8 on both sides of my equal sign, then just do it. Now, I'll have a bunch of people who will tell me, no, but I like writing that down. It's good. It helps me. And I'm just going to argue to you, you're just being stubborn a little bit. That is, let's work past stuff that we did in the past that we don't really need to do anymore. If we understand that we're going to divide out that coefficient of 8, then just divide it out. And let's get a little better with the stuff we do. Okay, as I said earlier, I think I probably caught up to some people, or there's some people that feel a lot more comfortable about tackling B. Or maybe the solution you have to B, you might go, oh, wait a second, I want to change that. Well, if that's the case, then I want you to pause the video now, make your adjustments, and then come back and we'll walk through a solution. Otherwise, we are up to speed, and now we're going to walk through a solution to B. Okay, I just want to take a look at one step that you may have tackled at the very beginning. That I'm going to bet and say at the very least, we hit the brakes considerably on B. That is, you look at that and you go, ooh, I got fractions. And so we at the very least went a little bit slower through B than what we did in A. That is, some people may have even said, okay, I have 2 fractions on the right side. I need to subtract those fractions. That means I need to get a common denominator. So I can change 2 into 4 by doubling it. Therefore, I double the top. Like, even writing that down drives me nuts. If you know enough to double it, do you really have to write times by 2 times by 2? So as I said earlier, let's work to be a little bit better. Now, if you went through that process, that then at least allows you to get that right side down to 1 fraction, of which our 2x's cancel out and we're off to the races. I'm going to argue to you, I never solved that equation that way. Now, if you did, there is nothing wrong with that. I might just argue to you, there's a more efficient route. Or maybe a route where you get to manipulate that equation into something you are very comfortable with. So I'm going to erase out all of that red. But if you had something like that, no worries. All I'm going to ask you to do is don't be stubborn and be open to solving that equation a different way. Now, I am hoping that most people, when they see the equation in B and they see all those divide bys, that's the part that slows them down. They're fractions. But the more that we can just see fractions as divide bys, the better we're going to be at solving equations. Because if we're comfortable dealing with opposite operation to the other side, then I think we can get rid of all those divide bys. Notice that for me to get rid of my first divide by 3, that means that I would have to multiply by 3. For me to get rid of my divide by 4 would mean that I would have to multiply by 4. And for me to get rid of my divide by 2, I would have to multiply by 2. Well, actually, I can even shortcut this a little bit. Because if I look up in the top there, my times by 2 is already taken care of because I multiplied by 4. And there's a 2 in a 4. And so if I take a look, I can get rid of all of my divide bys by multiplying by 3 and then multiplying by 4. There's me multiplying by 12. So there's the fastest way for me to get rid of all of my divide bys. Now, I am hoping that in our past, that's been a pretty comfortable process for us. My suggestion to you, though, if you are very used to getting rid of your divide bys by multiplying first, I would just put quick brackets around every term. By putting in those purple brackets, it just reminds you to multiply everything by that 12. So I'm going to multiply the first term by 12, the second term by 12, and the third term by 12. Now, I'm going to have some people that take a quick look at that equation. They go, hold on a second, Gray, you just goofed up. Because you multiplied the left side by 12, but you multiplied the right side by 2 12s. And I just have to stop you there for a second and make sure that we are comfortable that, no, I didn't. I multiplied it by 1 12. I just want you to notice that if I get rid of that second 12, and I get rid of these brackets in here, can you see that really I multiplied both sides of my equation by 12? Multiplying the left side by 12 is obvious, but notice I multiplied the right side of my equation by 12. It just so happens that my right side of my equation has 2 terms. And so if I'm going to multiply that by 12, then I have to multiply the first term by 12 and the second term by 12, and maybe we can see why we had 2 12s there. So I don't ever have to worry about that if I put brackets around every term and then ensure that I multiply every term by that same value. Now, I'm not really going to multiply by 12 because the whole reason I chose that 12 was to eliminate my divide bys. So now I can do my divide by and calculate my 12 divided by 3. That's 4. I can do my next divide by. 12 divided by 4 is 3. And I can deal with my last divide by. 12 divided by 2 is 6. Now, nobody is freaked out by the fact that, hey, look, all those divide bys worked out nice and neat. Because remember, we chose 12 because we knew that all of those divide bys would divide out evenly. Okay, some people are going to write this next line down and say, okay, well then I have a 4 times an x plus 4. I don't have to worry about my divide by 3. I already did it. Equals 3 times 2x minus 5 minus 6 times x. However, I'm going to argue to you that I would have a lot of people that would be very comfortable seeing that step by saying, okay, I need to expand in my 4. Now I need to expand in my 3. Well, there's nowhere to expand in on my 6, so I just multiply it because it was one term. And notice you could come straight in on the green line. Now, why do I like that? Because that actually looks like an easy form of equation A. And so I just want you to notice before we finish this one off that your best bet to solve an equation that has fractions in it is probably to multiply out those divide bys. Turn it into something that you're quite comfortable with. Now, you can treat that like a good old grade 9 equation and go as fast as you can go. Okay, maybe I simplify the right side. My 6x's are going to cancel out, and I'm left with my negative 15. Now I can get my variable all by itself. Sorry, my variable term all by itself, and now get my variable all by itself. And there we go. So hopefully we matched up with question B. We were able to work our way down. If we did keep the fractions in there for a while, then maybe you were just reminded of a strategy you could use to simplify your equation early. Okay, again, hopefully the rust is coming off a little bit and we're getting back into shape. We're getting back used to working through some of these problems. Okay, let's take a look at our next ones. Okay, I'm going to leave these two up on the screen for you, and same thing. Let's try to work our way through and see what we can remember, see what we're used to. Okay, I want you to solve both of those situations. Pause it now. Okay, we're back. So, for us to take a look at question C, we should notice that we can't put our two variable terms together into one term. We can't collect them. So our motivation then should be to get all of our terms on one side of the equal sign. Now that I have that in standard form, we're hopefully looking to factor. Don't be alarmed if factoring caused a problem. We're going to do a full factoring review, but this will just give you a little bit of an indication of, do we need a little extra factoring practice? I don't care how you go through and factor this. I would just hope that we'd be able to factor it in one step. Use some sort of fast factoring method. So, two numbers that multiply to give 2 would be 2 and 1. Now I'm jumping down. Two numbers that multiply to give 12. Well, I got 4 and 3. Well, if I do this and I go 4 and 3, then when I multiply across, there's an 8 and a 3. That can get me my 5. So all I need to do, if I get rid of those arrows in the middle and then just clean up a little bit, that was my 4, is if I had a positive on the 4, then 2 times positive 4 gives me 8. 1 times 3, if that's a negative 3, gives me negative 3. All I need to do is put in my brackets and my variables, and there I am factored. And therefore, my x is going to give me 3 halves from my first factor, or negative 4 from my second. So, as I said, don't be alarmed if factoring caused us a bit of a wrinkle. We probably have quite a bit of rust buildup there. We're going to deal with a whole factoring review. In fact, 2 days of it. But if we were able to work our way through, hopefully that's what we've got in blue. Okay, take a look at question D, and we should notice that in question D, you've actually been given 2 equations. So we have a system of equations in question D. And anytime we are asked to solve a system of equations, then we're asked to go through and find the value for each variable. So hopefully we've got some good communication and you have labeled both of those equations as equation 1 and equation 2, put a circle around it. That's universal. And I would love it if we used elimination in this case. Like, I would love to see that maybe we doubled equation 1 by multiplying everything by 2. We have now unsimplified that equation, so it becomes equation 3. And between equation 2 and 3, if we were to subtract those 2 equations, our x terms would cancel. Now, I would really like to take equation 3 and subtract equation 2, because then my 2x subtract my 2x cancels out. My 8y subtract my 5y gives me 3y. And my 6 subtract 3 gives me 3. Now, when I go through and solve for y, I get a y value of 1. I can now sub my y value of 1 back into one of my originals. We are probably going back into equation 1 because it's a little simpler. When I do that, I now get x plus 4 times 1, which is 4. And pretty quickly, we're able to get down to an x value of negative 1. And we could then state our solution in alphabetical order down at negative 1, 1. So I would love to see a solution that looks something like that. All of your red is your communication. Make sure that we have that included. If you have something different, then I would have expected a lot of people to just have taken equation 1 and got the x all by itself. And now we would have went and subbed equation 1 into equation 2. Wherever I saw my x, I can sub in 3 minus 4y. And maybe you went through and you tackled it that way. If you gave me the green solution, then you defaulted to elimination. If you gave me the blue solution, then you were maybe a little bit of a substitution junkie. You defaulted to substitution. We want to be good with both methods. However, if you're given a linear system, in most cases, elimination is probably going to be a little quicker. Okay, for today, who cares what method you used? I think we're doing great if we were able to solve that system. Clearly, you could finish off solving with the blue. We should be good. We can see the solution that we should come to when we solve that way. Okay, as I said, hopefully we're knocking off some rust. We're getting back into the swing of things.